critical points. It's an interesting term, critical points. Here's the definition. Basically, any time when the derivative is equal to 0 or is undefined, we call those critical points. So basically, if the derivative is equal to 0, that's where we have a horizontal tangent. And so on a graph, you would expect to see a turning point. If the derivative is undefined, what's that telling us about the graph? The function could be defined at the point. We're saying the derivative's not. Yeah, well, it could be a sharp point, maybe, that sort of thing. But there's another thing it could be as well. A vertical tangent, it might be. Yeah. Because if it had a vertical tangent, the slope would be, infinite, so the derivative would be undefined. But definitely something's happening at that point. So it's worth investigating. Now, when people say critical points, they tend to be meaning the undefined ones, because stationary points has its own special name. But technically, stationary points are critical points as well. It's all right. Let's draw a graph. Here's a graph. That's a maximum turning point. It's a critical point because the derivative is equal to 0. That's a minimum turning point. It's a critical point because the derivative is equal to 0. Oh, cubic. Over there we have what's called a horizontal point of inflection. But again, the derivative is equal to 0. So it's a critical point. Or sideways parabola. At that point, we'd have an undefined derivative. So vertical tangent. That's a critical point. This is what we call a cusp, where it comes into a sharp point. So again, that one, the curve, it's wrong to say the curve's not continuous. It is continuous. It's not smooth continuous. But again, if I was to draw a tangent at that point, I'd get a vertical tangent there. So that is also a critical point. Oh, nice. Told you it was quick, eh? How about that?